The GC has been equilibrating for a good half hour, a little bit more. 150 injection temperature, 65 column, 200 detector. So now we're ready to make our run. So the first thing we need to do is tell it where we're going to store the data. So I'm going to go to single run here. Actually, the first thing I'm going to do is, using the select project folder, I'm going to point it to my folder where I want the data stored, which is the 2020 Fall Lab folder. And then I'm going to go to single run and sample login. And I'm going to tell it that the carrier gas pressure is actually 90 kilopascals, not 120. And the split is open 6 turns, so that's accurate. And I want to point this to my data folder, the 2020 Fall Lab. And I'm going to call this n-butyl halides. There's my file name, and then under sample name, that's where you would put your lot number. I can't remember what page I said I was on, since I'm not actually writing any of this down. So I'm going to call it DCL-10-NBU-1. Right. So this is the first piece of data I've gotten on the n-butyl stuff. So the sample name, that's where you put your lot number, or your spectrum number rather. Sample ID we usually leave blank. Data file can be anything you want. And then under the data description, carrier gas pressure, 90 kilopascals, split open 6 turns. And I'm going to add to that mixture of n-butyl bromide, and n-butyl chloride. And OK that. So now I'm ready to make a run. I'm going to start the software here with this green start button. And it will transmit those parameters over. And it will say standby when it's ready. So it'll go from ready to ready standby. That tells me it's ready for me to make an injection. So I can take the parafilm off my vial. Remember, this was the one that I spilled most of, so there's not much sample. You have to be a little careful. And the septum loves to turn itself over when you uncap it. So I want to reach my syringe into just the liquid part and make sure I don't get any of the solid. I'm going to kind of guide the needle with those 2 fingers. And I'm going to flush this with my sample a couple of times, just to make sure the syringe has nothing in it except my sample. And then I'm going to pump it back and forth 2 or 3 times to make sure there are no air bubbles in it. And then fill the syringe to 1 microliter. 10 microliter syringe, 1 microliter is right there. And I'm going to try to put the cap back on there without knocking it over. In one hand. Yeah, that failed. Teflon side towards product. Because I don't want this to evaporate in case I need to make another injection. Test my one-handed skills here. So I'm applying a little lateral pressure here to make sure that the plunger doesn't pop, because when I put that in there, it's under 90 kilopascals pressure. It's going to try to blow the plunger up. What I need to do is insert the syringe all the way down in so the tip is in the injection port, so that the glass is just on top there. It's going through a rubber septum, which looks like this. It's one of these little green septa. So there's going to be some resistance, but if I have it going in at the wrong angle, then it'll hit metal and that'll bend the needle. So I need to put that in there, press the plunger, pull the syringe out very quickly, because as soon as I put it in there, it's going to start evaporating some of the liquid off the tip, and I don't want to get some evaporated and then put the rest in. That's called a double injection, and that will lead to overlapping peaks. As soon as I've injected it, I'm going to hit this start button on the keypad here, which will tell the instrument I started, and will change this from ready standby to acquire. So I need to push it in, depress the plunger, pull it out to make sure I have one clean injection, and then press the start button. I need to do all that very quickly so that, as I said, I get one clean injection and I actually start the acquisition at the right time. So you'll notice it now says acquire. We're collecting data. This is just a 2-minute run, and while I'm waiting, I'm going to clean the syringe by pulling up some N-hexane just to make sure that there's no residual n-butyl halides. In the syringe. Yeah, 4 or 5 times. Usually pretty good. If all goes well, I won't have to inject that again. I'm just gonna kind of wipe that off, clean that a little bit. So we have a nice freely moving syringe. The first peak that comes off looks like it's just shy of 0.9 minutes. That's the hexane, the solvent. And now we're waiting for our other peaks to come off, and hopefully they'll still be on scale. So it looks like there's a peak there, there's a couple of peaks in there. One of these here is probably the n-butyl chloride. This one out here is probably the n-butyl bromide. My guess is that's the n-butyl chloride. If I blow these up, you'll see there's a lot more solvent than there is product. So this is probably another solvent peak. We got our chloride and our bromide. Or perhaps that's the chloride and the bromide's not off yet because we're only at 1.8 minutes. Undo my zoom. The instrument's going to keep collecting data, even though it's no longer sending the data to the computer. So I can tell it that I actually want to see 10 minutes worth of sample here. So it actually kind of looks like there's a second peak here that came off too late and wasn't detected. And I may need to do another injection and let this go for a little longer. Like I said, from year to year the pressures change, and so the pressure in the cylinder changes. So even though we have it set at 90 kilopascals, the flow rate may be varying. So I'm not entirely certain exactly what I'm looking at on the data there. But I'm going to go to post-run. I'm going to open up my n-butyl halides chromatogram. And it looks like n-butyl bromide should come off at about 1.15 minutes, right? So that big peak was the n-butyl bromide, and this early peak at 0.932 was the n-butyl chloride. I suspect that this peak at 0.899 is in fact not n-butyl chloride. That's almost certainly a solvent, residual solvent peak, and it may be because the N-hexane has a little contamination with methyl cyclopentane. But I can get it to not integrate that so that I don't see that peak that I don't want. So I'm going to go to the Edit menu, and I'm going to check for method. It looks like I'm turning the integrator off at 0 and back on at 0.800, and then I have a reject peak at 0.805, but that's not where that peak is this time. That peak's actually at 0.899. So I'm going to change that reject peak at 0.805 to 0.9 and OK that. And then when I go to view here, it looks like I need to maybe turn the integrator off, not turn the integrator on at all until about 0.86. And that should make those peaks go away. So I'm just looking at my n-butyl chloride at 0.932 minutes and my n-butyl bromide at 1.153 minutes. And it looks like about a 19 to 81 area percent mixture. I'm going to save that data file with the correct integrations in there. I could, in fact, if I wanted to, go to the Edit menu and go to this compound. Last year, the n-butyl chloride was at 0.90 and the n-butyl bromide was 1.19. I could actually change that to 0.93 and 1.15 if I wanted to reflect this year. They were close enough that it was picking them up correctly anyway. And again, I can save the data file. So I'll have to put that in a report form. But I'm going to go ahead and do another injection to see if I can get it maybe a little bit cleaner. And because those peaks are getting close to overlapping, I'm actually going to change the temperature from 65 to 60 to hopefully slow things down a little bit, because it looks like my pressure is a little higher this year than it was last year. So I'm going to save the method file as well. Now that I've edited it. Save method as, and I'm going to call it n-butyl halides 2 underscore 2020. So I know it's this year's method. And I'm going to close the data file, save it, sure, why not. And now I'm going to go and open that method. I'm not going to save the current one, that's not necessary. And that is under the data GC. (260) methods. Should be n-butyl halides 2 2020. I'm going to go back to sample login and simply change this from n-butyl-1 to n-butyl-2 and change the data file by adding a 2 on it. I'm going to OK that. And what I want to do is I want to change the column temperature from 65 to 60. The initial temperature. Enter that. I'm going to hold that for 2 minutes, and I'm going to save the method file again. And now when I go to sample login, OK that. So now when I press start here, it's actually going to load those new method parameters, and it will cool this column down from 65 to 60. you'll hear the fan come on. And it says not ready, standby, because it hasn't actually equilibrated to 60 degrees yet. So I can take advantage of that time to flush the syringe with my sample again, ready for the next injection. Again, I'm being careful not to get any of the solid into the syringe. And then I want to pump it a few times to get rid of air bubbles. And take out 1 microliter. See if I can do a cleaner job of getting that lid back on there this time. So now it's hit 59.5. It overshot a little. It says it's ready, but I'm going to wait for it to actually equilibrate to 60. This will change the retention times a little bit, so I'll have to adjust them in the solvent table. .9. So now we're at 60. So now I'm going to do the same thing. Push the syringe in, press the plunger, pull it out, and press start. And it will change from ready standby to acquire. So we're collecting data again. And while I'm waiting, clean the syringe. I'm hoping to get a cleaner separation between my solvent peaks and that n-butyl chloride, so I'm certain that none of the solvent peak is underneath the n-butyl chloride. I don't need the n-hexane anymore. So I'm pretty certain that I can work with the